Okay, for the class practice questions, question 1 to question 5 are pretty much very simple basic questions which I think you can handle. So please try them on your own and then check your answers. Okay, if you have any questions, we can always discuss this in class on Thursday, okay, or tomorrow. Alright, so now I'm going to look at question 6 of the class practice. If you want, you can also try this on your own before you watch the video. Okay, so question 6, they tell you that PTS and QTR are straight lines. P is a point negative 15,4 and S is a point 6,4, where the vectors of PQ is given. So PQ is given to be 5, 8, and RS is given to be 2 times of PQ. So if I were to sub that in, that would be 2 times of 5, 8, which is 10, 16. Okay, so now you're asked to find the coordinates of Q, right? So in this question, it is all about vectors. So in order to find coordinates of Q, you should find OQ first, right? So find OQ. Okay, so given PQ and given P, you have OP, right? So PQ is given by OQ minus OP. So OQ is PQ plus OP, which will give you negative 10 and 12. Okay, so therefore Q is negative 10, comma 12. Part A's answer. Okay, so for part B, we find the coordinate of R. Okay, so similarly, you know that RS is 2 times of PQ, and RS can be expressed as OS minus OR. Okay, so to find the coordinates of R, just do some rearranging. OR is given by OS minus RS. OS coordinates are given by 6, 4. And RS is 2 times of PQ. So that will be 2 times of 5, 8. Okay, so this should give you negative 4 as well as negative 12. And therefore, R is negative 4, comma negative 12. Okay, so part A and part B relatively simple. Okay, now let's look at part C. Prove that triangle PQT is similar to triangle RST. Okay, so if you recall, the proofs for similarity is almost all the time regarding angles. Okay, so similarity test, we have AA, that's the primary similarity test. There's also SAS and SSS, which are seldom used. Most of the time we use AA. Okay, so we just have to prove that there's 2 corresponding pairs of angles that are equal. Yeah, so 2 angles that are equal, then we are done. Okay, so how do I prove that 2 angles are given? I'm not given any angles in this question at all. Right? All I'm given is a bunch of vectors. Okay, but what can vectors tell us about angles? Or what's the relationship? Vectors can tell us that the lines are parallel, and if the lines are parallel, then it tells us that the angles are the same, right? Because parallel lines have angle properties. Okay, so that's the thinking process, right? We will have to use the AA similarity test. So we have to prove that there's 2 pairs of corresponding, there's a pair of corresponding angles that are equal. Okay, so yeah, first we are given that RS is equals to 2 of PQ. RS is parallel to PQ. Okay, so because they are parallel, we have the first property, angle Therefore, angle PQT is equals to angle RST. Okay, and this is alternate angles. RS is parallel to PQ. So this is your first statement. Okay, the second statement, you can either prove another pair of parallel lines. This is the angle, the first angle that I've mentioned. The second one, you can either prove that the angle PQT. PQT is the one that I've proven first. This is RST. Oh, PQT is equals to SRT. Yeah, so this is wrong. It should be SRT. Okay, so I'm proving this one. Let's see. Okay, so you can either prove P and S, or you can also use vertically opposite angles. So up to you, right? You can also use vertically opposite angle. Angle PTQ is equals to angle STR because of vertically opposite angles. So you just need two statements, two angles. The third angle is given because, you know, the third angle is 180 minus two angles to get the third angle. So we just have to prove AA, sufficient already. Okay, so therefore, by AA similarity test, triangle PQT is similar to triangle SRT. Okay, so that's done. Okay, then part D. Hence, find the ratio of the area of triangle PQT to the area of triangle RST. Okay, so what is the formula for the area of two triangles? Do you all remember what is the formula for the ratio of the areas of two similar triangles? Okay, let's do a quick throwback here. When two triangles are similar, then their areas ratio is given by their length ratio, the whole thing square. Okay, so in this case we are finding PQT over RST, right? And we know that PQ, or rather, yeah, given that RS is equals to 2 times of PQ, we know that okay, so we want PQT to RST, right? So PQT should be the numerator. Okay, so I'm going to divide by 2, bring the 2 over, so that gives me half. Half of RS. Okay, then divide the RS to the other side. So I will get PQ over RS to be half. Okay, so given this, therefore, the area of triangle PQT over area of triangle RST is given by half square, okay, which is 1/4. So therefore the answer is 1:4. Okay, so this is question 6.